What's Palmer's first step? Yes.
Taking the C out of all the beautiful.
Okay, taking a C, factoring a C out of all. Factoring out C. Factoring out a C. So taking C, putting it outside the parentheses, undistributing it, writing it as C times something else. All those things mean factoring. So in the second step, what kind of polynomial is this that he factors? Yeah?
Quadratic.
It's a quadratic. How do you know it's quadratic?
A squared plus b squared plus c. Or no, a squared plus b, or x squared plus, it's in the standard quadratic form.
Yeah, ax squared plus bx plus c. Yeah. It's got, the highest power is 2, it's a degree 2. So yeah, that's a quadratic. Worthy did not factor this polynomial completely. So in this first step right here, before he even actually writes anything down, he circles those two groups. Why does he do that? Why does he circle those two groups? Why don't you write it down? Down one there. What do we got? Why is he doing that? Yeah, we did.
You take which one you prefer. You take that ends, and you should take the first term, take that ends out of that first group.
Yes.
And in the second one, you take the that comes out.
Yeah. So he's just factoring by grouping. And factoring by grouping is exactly as Chance described it. We look at the first group and factor out what they have in common, and squared, what does this have in common? -9, we factor those out. So he's using this. When you look at that problem, when you start it, you look at number 20, and it looks the way it does. What about it tells you you're probably going to use factor by grouping? What's that?
Four.
There's 4 terms. You're going to get 2 groups of 2. That's what you want to get. So there needs to be 4 terms in order to use factor by grouping. Really, any polynomial that has an even number of factors, or even not only that you can group into equal groups. You could do, if you had 6 terms, you could do 2 groups of 3, 3 groups of 2. If you had 9 terms, you could do 3 groups of 3. But the simplest case would be 2 groups of 2. So we group those first 2 together, and the second 2, and we look for what they have in common. So all that looks good. You factor out the n squared and the -9, you got n plus 5 and n plus 5. That's good. And then he goes to factor it out, but he's not done, or he hasn't done it completely. Why not? Okay.
Because n squared minus 9 cannot be factored out more.
Yeah, what do we call that? It's got a special name. It's a difference of squares. So we can factor it as a difference of squares. So we can say n squared minus 9 is a difference of squares. So n plus 5, that's not going to factor anymore. How would n squared minus 9 factor?
N squared minus 3n squared plus 3
Just, because keep in mind we have to multiply these together. So if we had n squared times n squared, you get n to the 4th. So we'll bring down an n and n and n times n squared. Questions so far? Quentin does not find the solutions to the polynomial correctly. Yours is correct. So again, it's factored by grouping. In the second group, what common monomial does he factor out? factor of -1. When you factor out the g squared, from these terms you see you get a g plus 3. And you know over here you're going to want in this parentheses to get a g plus 3. But since you have a negative g minus 3, you need to factor out a negative so that we can do negative times the opposite of these. So that if we distribute the negative, we get the negative g minus 3 again. So the two parentheses are identical. So -1, so we take out the second group. So let's, I mean, if you did all this factoring correctly, you even got the difference of squares. G squared minus 1 is the difference of squares. G plus 1 times g minus 1. What's he still got to do if he wants to find solutions?
Set each one to 0.
Yeah. Set each factor equal to 0. G plus 1 equals 0. G minus 1 equals 0. G plus 3 equals 0. If we solve each one of those, G equals -1. G equals 1. G equals -3. So set each. What are each of these things called? This and this and this. They are these things, the word that I'm looking for, because they're just multiplied together. I can multiply these two things together and get the original polynomial. So if we can multiply these things together, they're called factors. So set each factor equal to 0. Is it really important that they're equal to 0 and it's not, say, equal to 5? Why is that an important part of this solving thing?
So you know that one of them is equal to 0.
One of them, because we're multiplying them together and we get 0, one of those factors has to be 0. No other way to do it, right? If we had 1 times 2 times 3, that's not going to be 0. 2 times 7 times 14, that's not going to be 0. The only way that we can get 0 if we're multiplying is for one of those things to be 0. And on the flip side, if it were equal to like 5 or something and not 0, well, there is no guarantee in that case. You can't say one of them has to be equal to 5. It's not true. That's not necessarily true. Okay? But in this case, one of these absolutely must be equal to 0. Otherwise, that equation couldn't be true. Well, that's all three of what I had. You guys have any other questions?
Six.
13, 46, okay. Remember, I tried to help you out classify what different types of factoring patterns we use, like quadratic form, difference of cubes, sum of cubes, difference of squares, factor by grouping, all these different ones. By how many terms there were. How many terms does this polynomial have? 2. Okay. And what are all of the patterns that would fit possibly when you have 2 terms? Sum or difference. Which kind can have a sum or a difference? See, both of those are factorable. Quadratic form, it's not necessarily a sum or a difference. What are all those ones that start with sum or difference? Squares, cubes, difference of cubes, sum of cubes. Okay. Difference of squares, no sum of squares, no sum of squares, only difference of squares. Sum of cubes and difference of cubes. Alright, so is this a difference? It's not even a difference. There's only one that it could be, which is what? Sum of cubes. Only if it's sum of cubes. So only if you can write this like this. Something cubed plus something cubed. Can we cube something to get 216? What? 6 cubed is 216. Can you cube something to get 125n cubed?
5n.
What's that?
5n.
5n. 5 cubed is 125, n cubed is n cubed. And because I took the time to do this, bring it over. Here's our sum of two cubes. So a in this case is 5n. This whole thing is a, and this is b. 6 is b. Just plug it in. So we get 5n plus 6 times 5n squared, that'd be 25n squared, minus 6 times 5n, 30n, plus 6 squared, b squared, 36. Sum of cubes. It comes down to some practice and just pattern recognition. You see two terms, you think, well, there could possibly be a difference of squares, and that fact could be difference of cubes, could be a sum of cubes. These are the things I'm going to check for. Or maybe before I even start, I can factor out a common factor from all of them. But that one just happened to be right away difference of cube or sum of cubes, ready to go. And 46. You're in 46. So what first? Yeah?
Factor out c squared.
Okay, c squared. Anything else that can factor out all these? No, let's see, there's 2 for the 2 doesn't factor into that. Maybe a 3. Does 3 factor into that?
Yeah.
It does, but then it doesn't factor out 10. And after 2 and 3, there's just not a lot of options after that because everything is either even, so none of those are going to work. Then your 5's not going to work, 7's not going to work, and then it doesn't take long before you're just out of options. So c squared can come out of all of them. We got 18c squared plus 57c minus 10. Maybe even that's all you can do, but maybe not. Because what kind of a polynomial is this? Quadratic. It's 2, so we should be able to factor it. If you're real patient, you could try this. Maybe a 9c and a 2c. Because that's 9 times 2 is going to be 18. C times c is c squared. Then try guess and check the factors of 10 that might plug in here and work out, but then none of those might work. You might have to go to like 6 times 3 instead of 9 times 2, or 18 times 1. And it could be a long, long process. So that's where we use an AC method. If you choose, this is what I choose to do. So what goes here? AC. So there's A, there's C, and so that's negative 180. Here is B. And what are we looking for here? 2 numbers. Factors of negative 180, that also add up to 57. Okay, I can take a minute. Anybody found them? Got them?
Yeah, negative 3 and 60.
Negative 3 and 60. Let's just make sure 60 times negative 3. Yeah, negative 180. 60 minus 3, 57. Great. And we get rid of all this. What do we do with that negative 3 and that 60? And we'll just plug them into the factors. That's a mistake that happens quite a bit. It doesn't just get plugged into the factors like you just know it's 9c minus 3 and 2c plus 60. That's not how it Yeah?
You just write negative 3c plus 60c.
That's right, we split apart the 57 into two like terms, right? Negative 3c and 60c. And then we use factor by grouping. Two groups of 2, factor by grouping now. C squared. What does this group have in common? C. Anything else?
3c.
3. It gives us 6c minus 1. And these two?
10.
10 is a big one. We get 6c minus 1. Perfect. That's exactly what we wanted it to be. C squared. So we can factor out the common factor of 6c minus 1. We get 6c minus 1 times 3c plus 10. Definitely all factored down. There's no sum of cubes or different squares or exact factoring factor. So we're going to call it good. Other questions?
Number 26.
Okay, so this is not factored by grouping. It's not a difference of squares, a sum of cubes, difference of cubes. It's not a quadratic, right? Why is it not a quadratic?
Degree is 4.
Degree of 4, quadratics are all degree 2. What are we down to? Take notes, you should have just one more left. Not factored by grouping, it's not 4 terms, yeah?
Was it quadratic 4?
Yeah, it's not a quadratic function, it's not a quadratic polynomial, but it is a quadratic form where it's like this. It's like 3s squared minus s minus 24. But it's not s squared, it's s squared squared. And it's not s, it's s squared. Remember, if it's 3 terms, if this is a constant, and you can take this and square it, and get this term, if you can square s squared and get s to the 4th, we're looking at quadratic form. Which means we can factor it into 2 factors, like we've seen before, where this gets an s squared instead of an s, and this gets an s squared instead of an s. One of these is definitely going to be a 3s squared, right? There's no other way to factor 3's, that's helpful. So you could guess and check, probably wouldn't take too long. It might be a little faster to guess and check in this situation than to use the AC method. Tough call. Like negative 3 and 8. So 3s squared times s squared is 3s fourth. 3s squared times negative 3 is negative 9. Here we get 8s squared and negative 9s squared. That is a difference of 1s squared. And 8 times negative 3 is negative 3. Let's pass in our homework. Please. Alright, to start off today, we're going to pick up, go back through the thing we did at the end of last class. Is someone run through this imaginary scenario that I set up last time? Explain the story behind this a little bit.
Basically, you said you find a piece of paper, torn in half, so it's homework on it. You
Yeah.
decide to find the missing factor.
Perfect. Yes. I like that you use the word factor. We're looking for this missing factor. There's something that you can multiply x plus 2 by to get this. Okay? And so I think I told you that this ties into, well, it is long division of polynomials. It just looks a little different. So now we'll start to go through it again, and I'll show you how it's exactly the same as long division, rather than just showing you long division, having it be confusing, and then trying to explain it this way, and just kind of trust me, this is the most successful I've seen it go. So we said we'll start to piece it together little by little, right? So we took a step one. What was step one in finding this other factor piece by piece? No, we didn't. Jade?
We put it 2x squared, I think it was,
No, why do you do that?
because that times x is 2x to the third.
We know that whatever this is, and this is pretty, I don't know if I'd say profound, that might be too strong, but it's significant that we recognize that this multiplied by whatever this is needs to give us that. It's the definition of factors. So whatever is here needs to multiply by that to give us this. So the first thing we know that we're going to need is a 2x squared. It's the only way we're going to multiply this by something and get a cube. The only hope we have of getting a cube is to multiply x by something squared. We could put an x cubed there so that we get 2 times x cubed is 2x cubed, but then we're going to get an x to the 4th, and that's not going to be more than 1, right? So we'll always look to the biggest power of x over here to get us started. So x times 2x squared is 2x cubed, just like we wanted. But then we found out what?
You gotta do the factor over the 2
Right.
also.
Gotta distribute it to the 2. So when we distribute it to 2, we get 4x squared. Okay, so now things are not going as we had hoped. Right? Why is that?
'Cause you're over by 2.
2?
Yeah, you're 4x and squared, and you're.
We're over. How much are we over by?
3.
We're over by 3.
Yeah.
What do we want to get?
2 cubed.
Well, we have that.
X squared.
We want to get a 1x squared. We have 4 of them. Right? So we want to take back 3 of them. So we're off by that much. Okay? We good so far? Everybody's good? Any questions? Now's a good time to ask questions if you have questions. All right, so now I'm going to show you how that first little bit is exactly what we do in long division. I'm sure you've done long division before. You've done it with numbers, never with polynomials. Pretty confident in that. And it's exactly the same process. If you've ever done long division with numbers, it's the exact same with polynomials. Okay. So we put the x plus 2 out here. We're dividing by x plus 2. We're dividing that into 2x cubed plus x squared minus 5x plus 2. When we're asking ourselves, what's this other factor? That's what division is, right? This times what gives you that? That's what division is. That's the question. Okay. If we saw a 15 and a 3, and the paper was torn like that, and we were saying, well, 3 times what equals 15? That's exactly what division is. It's 15 divided by 3 gives us that number. Okay, so we take the polynomial, divide it by the factor we already have, and try to find what that other factor is. So the first thing we do is say, well, this up here is going to be the other factor, which means if this is the other factor, what am I going to be able to do with this and whatever this is? Should be able to take this and do what with it? Whatever this turns out to be. We don't know what it is yet. We're looking for it, but once we find it, what should we be able to do?
You should be able to plug it in up top.
Plug it up here?
Oh, over the actual one that we're actually going over.
This one?
No, I think he means the polynomial.
Yeah.
It should be this.
Yeah.
It should be this. So it should be exactly this, which means we should be able to take those 2 and do what with them?
Multiply them together.
Multiply them together and
And come out with that.
come out with that. Yeah, exactly. Okay. So what we set up here is exactly the same scenario as what's in red. We know what we want to divide. We know what we want to divide by, and we're trying to find what the result would be, what we can multiply x plus 2 by. So first we say, what do we multiply x by to get 2x cubed? Just like we said it here, what are we going to multiply x by to get 2x cubed? The answer is the same. That's a square. 2x squared is what we multiply by. And then we check and see how we're doing so far. 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. And so what we notice in the long division, they're lined up right there next to each other. You can see it's not lining up the way you wanted it to. You wanted to get x squared, but you got 4x squared. So if we take the difference, so at this step if we subtract, we find that here we get a 0, which if you didn't get a 0 there, that'd be bad, because that's why you multiply by 2x squared, was to get 2x cubed. And 2x squared times 2 is, that's not x squared minus 4x squared is negative 3x squared. If we take 3x squared away from 4x squared, we'll get the x squared that we wanted. That would kind of fix the situation. Right? That's what we're saying here. If we can subtract 3x squared from 4x squared, we get x squared. So how are we going to do that? Where in the world are we going to come up with a negative 3x squared? How can we make that happen? We could put into this factor that would wind up giving us a negative 3x squared. Connor?
Negative 3x.
If you put a negative 3x there, and we multiply negative 3x times x, we get negative 3x squared. So now we're good. We're back on track with the x squareds. Those are good. But then what happens?
Get a negative 6x.
Get a negative 6x. Do we want negative 6x?
No, you want 5x.
We want negative 5x, negative 6x. Okay, so it's the same thing we do here. How do we get negative 3x squared? With a negative 3x. Negative 3x times x, we just do the same thing we just did over again. Negative 3x squared, great, that's what we wanted. Negative 3x times 2 is negative 6x, not so great, because we wanted a negative 5x. So this step, the subtraction step, just finds out what do we need to add back onto negative 6x to get back to negative 5x. Okay, so a negative 5x minus a negative 6x gives us x. So we need x more, right? The same thing right here. We're just reasoning, if we could add x back onto negative 6x, we could get back to negative 5x. How are we going to get that x? Where's that x going to come? What are we going to put in here in order to get an x? Plus 1. 1 times x gives you x. And here's the part where we just hope that this last thing works out, because if it doesn't work out, then we really don't have anything else that we can put in here. We're down to just numbers, just constants. 1 times 2 is 2, that is what we wanted, and so we have a remainder of 0, that's great. If we were to collect like terms, 2x cubed plus x squared minus 5x plus 2, that all worked out. Same thing here. Back to this step. How do we get an x? We multiply by 1. 1 times x is x. 1 times 2 is 2. We wanted to get a 2. We bring that down to compare. And if we subtract, we find nothing is left over. So whether you look at it as long division or just what's that other factor? How do we, what pieces do we need to plug in each step of the way to make sure that we're getting the things that we want to get when we distribute? They're both the same thing. The long division thing is just a way to put it into an algorithm that's the same every time and is just real specific. It has the same set of steps for every step along the way. You guys ready to try long division, or do you have any questions before you try? Okay. It may not go perfectly smoothly. That's okay. We'll do it again and again, and you'll get the hang of it. So let me give you one. I'm going to put it on the same screen as here so you can follow the same steps. pen and paper and get working on this. Okay, so to say that we're dividing this by this is to say we're looking for whatever this is that we can multiply by x plus 2 to get this. Good? So we put it together little by little, and so we start with x cubed. How are we going to get x cubed? So you get x times the x squared, right? This first thing is going to be an x squared, because x squared times x is x cubed. So x squared times x is x cubed. Perfect, that's what we wanted. But x squared times 2 is 2x squared. We wanted to get what? We wanted negative 9x squared, not 2x squared. So we are off. So what would we have to do to 2x squared to get to negative 9x squared? Subtract 11x squared, right? That's why we find this difference. X cubed minus x cubed is 0. Negative 9x squared minus 2x squared is negative 11x squared. That's what we would have to add to 2x squared to get back down to negative 9x squared. That's what we wanted to get. Okay. So that's the next thing that we need to get, so that negative 11x squared plus 2x squared will give us negative 9x squared. How are we going to come up with a negative 11x squared? The next thing we put in here, we'll make it a negative 11x. Negative 11x. Next thing that we multiply by will be a negative 11x, so that negative 11x times x is negative 11x squared. So now we have it set up in such a way that x squared times x is x cubed, and x squared times 2x is 2x squared, but this negative 11x times x is negative 11x squared, so that 2x squared minus 11x squared is negative 9x squared. But also, we have to multiply that negative 11x times 2, so we might also get this negative 22x. And how many x's do we want? 8. We want 8x. We'll bring that down, just for comparison's sake. What do we have to do to negative 22x to get to 8x? Add 30x. Negative 22x we need to add 30x, big old amount of x, to get back up to 8x. That's why we subtract to find that out. We find out that we need negative 30x by taking 8x minus negative 22x. That's plus 22x. That's 30x. So we need our next thing. What's our next thing going to be so that we can get that 30x that we need to get? 2? 30.
Wait, 30.
Yeah, 30.
I was thinking that.
I think I see what you're saying.
Yeah.
So 30 times x is 30x. Perfect. Now we have 30x to add to our negative 22x to get us to 8x. Now we hope this last part works out, because we just don't really have much left over to add on to this. So 30 times 2 is 60. That is what we were going for right there. So if we put a plus 30, we reverse engineered this factor that we need. We got the x squared, so that x times x is x cubed. That was great. We needed an x cubed. But when we multiply the x squared times 2, we get the 2x squared. And we wanted negative 9x squared. So our idea was, well, we'll put a negative 11x here, so that negative 11x times x gives us the negative 11x squared, so that these two combine to negative 9x squared. That's great. But at the same time, we have to multiply negative 11x times 2. That gives us negative 22x. We want 8x, so we came up with this idea that if we add a 30x here, these will combine to the 8x that we want. So we put a 30 there. 30 times x is 30x. 30 times 2 works works out nicely to be 60, just like we want. X cubed minus 9x squared plus 8x plus 60. So all this long division thing is doing is to find another factor that will multiply by the thing you're dividing by to get the original polynomial. I'm going to get rid of so you might notice that you do long division enough times, and you're going to notice that when you have just a 1x to the first power there, it really all comes down to this number right here. This is the one that's kind of affecting all the decisions. So we only really need it to work with that 2. Because like whatever we put here, we're just going to multiply it by 1x. It's not going to change anything. It's just going to come down and be exactly what we want it to be. It's that 2 that causes all of the other things that need to happen. So really, it's just a 2 interacting with the numbers, these coefficients, and this constant. So if we were to just write down the coefficients, and the number 2, it would all be the same thing. Because we're trying to get x cubed, we're just going to multiply by 1x squared by x to get x cubed. It's not a big mystery what we're going to multiply 1x by. But it's the result of multiplying by 2 that causes all the difference. So what we have here is a setup for synthetic division, which is exactly the same as synthetic substitution. Bring down this 1, just like we have this one here. We're going to multiply 2 times 1, get 2. What do we do with this stage in the long division? After we multiply the 1 by the 2, the 1 by the 2, we subtract. So we subtract this. Negative 9 minus 2, negative 11. Look at that. 11. 2 times negative 11 is negative 22. We do what then? Subtract. Negative 22. That gives us 30. And 2 times 30 is 60. And we subtract the 60 and 0. Like the set of steps, the algorithm is the same every time. This number right here is interacting with everything else and causing all the problems. It is the thing that causes us to need to subtract and find the difference and find the new thing. But every time we ask the question, well, what am I going to multiply x by, 1x, to get negative 11x squared? I'm just going to multiply by negative 11x. That's one less power than this power. It's only when we multiply by 2 that we figure out what we need to do with the next step. Right? So this process is almost synthetic division, except for we notice we're subtracting in every step. So what we could do instead, to save ourselves a little bit of time, is instead of a positive 2, just make it a negative 2. And that way every step that you need to subtract, you've already multiplied by that negative, and you can just add it straight down, just like you would if you were doing synthetic substitution. We've done 1, negative 2 times 1 is negative 2. You just add them together. That's 22. You add them together. Negative 2 times 30 is negative 60. You add them together, you get 0. So I'm going to want you to try the synthetic division. Let's do something real quick. coefficients of the thing that I'm dividing. I looked at what I'm dividing by, x minus 1, so I put a plus 1 right there. Break down by 2. And then we start. 1 times 2 is 2. We add these together, we get negative 13. So add these together, negative 13. Add these together, 21. 1 times 21 is 21. We add this together, you get 0. Okay? So this is your remainder. This is your constant. This is your x term, your x squared term. If we had more terms working to the left, we had x cubed, x to the 4th, and so on. So when we divide this by this, what we get is 2x squared minus 13x plus 21. Just to check with you, what if we were to multiply this by x minus 1? What would happen if we multiply that by x minus 1?
It would become that first term without the division in the x minus 1?
Yeah, we just covered this up.
Yeah.
It would be this thing right here, the original polynomial. It would be 2x cubed minus 15x squared plus 34x minus 21. Well, now that we've divided out that x minus 1, now we've got this quadratic that we can factor. Take a second and figure out how that factors. Anybody got it? Yeah? Got it?
I did it the other way and just kinda did all the stuff to it and stuff like that, I wasn't really doing that.
Negative 11, negative 2. Would that work?
Negative 11, negative 2 here. Actually, that wouldn't. Yeah, 22. We want to get 21.
Yeah.
So multiplies make 21. 7, 3. Probably get pretty candidate. We're going to multiply make a positive 21. And then in the end, we're going to come out with a negative 13x. So whatever that is, whatever we put here, we also need to multiply them by the 2x and the x. Come out with negative 13x.
Negative 7 and negative 6.
Negative 6?
Mhm.
I think if you negative 3 would become a negative 6.
Oh, right, okay.
So let's see. 2x times negative 3 is negative 6x. Negative 7 times x is negative 7x. That does add to negative 13x. Negative 7 times negative 3 is 21. So when we divided out that x minus 1, we found that x minus 1 times the result, the quotient, is able to factor even more because we have this quadratic, which turns out to be factorable. So I could, in the fashion of numbers 21, let's see, 21 and 26 in your homework, give you a polynomial and one of its factors, and then you can use that factor, divide it out of the original, and then continue factoring from there. -15. Just another practice in using synthetic division. Something different about this one than previous divisions we've done? What's different? There's a remainder that's not 0. So let's discuss that. 1 and 4, add them together, we get 4, multiply -16, we get -15. I told you about this already. This is your remainder, this is your constant, this is your x. You get x plus 4. Okay, now we have to understand this remainder thing. Well, we got to -15 and we just stopped, okay? And like there was this remainder of -15 that goes unresolved, and it hasn't like been run through this process. It did not get involved in the division. We just stopped at -15. So -15 is still needs to be divided by x plus 4, and that's how we write. That's how we write the remainder. It's just the piece left over that is still needs to get divided by x plus 4, but there's no nicer way to write it than -15 needs to get divided by x plus 4. Okay. It'd be like if you were going to do 5 into 27. 5 goes into 27 how many times? It's 5, right? 5 times 5 is 25. But then we have 2 left over. What do we do with that 2? Well, our answer is 5 and 2/5. 2 still is being divided by 5 plus 2 divided by 5. Okay. We divide every part of 27 by 5. The biggest part, 25, can be divided into 5 pieces. The last 2 also needs to be divided into 5 pieces. Same thing here. We're able to divide x squared plus 8x plus 1 by x plus 4. Our main part is x plus 4 minus 15, which still is needing to get divided into x plus 4 pieces. So that's how we write a remainder. So we take the remainder over the original divisor. Most of the time, though, our remainders are going to come out to be 0. That's the situation we like. That's the situation that we're going to wind up having most of the time, like beyond this section. But it's worth visiting a remainder, what that means. Okay. So if I ask you to do a long division or a synthetic division problem, you come out with a remainder. There you go. That's what it means. Okay, so we divide x cubed plus 2x squared minus 51x plus 108 by x plus 9. What do we get? What is the resulting polynomial? Exactly. Okay. We divide this by that, we get that. So what if this by x plus 9. We multiply the result by x plus 9, what are we going to come up with? That original, right? That whole big thing, not this part, but all of that. If we multiply x plus 9 by the quotient, then we should come up with that. And again, we should be able to factor this further. X minus 3, x minus 4. Okay. Something we've already done. But now if this happened to be equal to 0, you solve this equation. How so?
You just gotta change those to equal to 0.
Change each of these factors to equal 0. Make them each equal 0. One of them's got to be 0. You can only multiply and get 0 if you multiply by 0. So we'll find that x is negative 9, x is 3, x is 4. We set them equal to 0, add 4 to both sides equal 4, add 2 to both sides equal 3. Well, notice I said x plus 9. I said divide by x plus 9. And it turns out we got a remainder of 0. Which means that we're able to multiply x plus 9 times the result, x squared minus 7x plus 12, and get the original. Okay? By definition, that means that x plus 9 is a factor, right? Because I can multiply by something else and get the original. It also means x squared minus 7x plus 12 is a factor, because I can multiply it by something else to get the original. Okay? They are factors. Well, if x plus 9 turns out to be a factor, okay, and I can set that equal to 0, and I can set that factor equal to 0 and solve and get x equals negative 9. From the very beginning, if I told you that x plus 9 was a factor, then what could you say about negative 9?
It's a solution.
It's a solution to this equation, yeah, it equals 0. Or, if we started it this way, f of x is equal to that polynomial. Right? Instead of telling you to divide, if I told you that. If I just told you about x plus 9 and said x plus 9 is a factor, it would be the same to say that that x equals negative 9 is a 0, meaning if I set this equal to 0, whatever value of x that I find that solves that equation is what you call a 0. And I can find the other zeros by setting, once I factor it down more and set each factor equal to 0, I can find the other two zeros. So in the latter problems that you'll find there, 21, 26, 30, 34, 30 and 34. One style will tell you, here's a factor. Okay, well, I'll use something synthetic division to divide out that factor and find the other factors, and I factored it. The other style will tell you, well, this is a 0. Okay. Well, if that's a 0, then x minus that thing, or x minus negative 9, x plus 9, is a factor. And then I can find the factors and set it equal to 0 and find the solutions and the zeros. Yep. That x plus 9 is a factor or that negative 9 is a 0. I mean, they're synonymous. If x plus 9 is a factor, negative 9, plug negative 9 into here, it'll give you 0. Or if I tell you that negative 9 is a 0, that means that x plus 9 must be a factor, because that's how you find out x minus 9. Right?